This puzzle is called Corpse Flower by rdndnt. I got it from the Sudoku Testing Submissions channel on the CTC Community Discord. I'm not sure how difficult this puzzle is. There's not a ton of clues, but most of the clues do seem pretty restrictive. I'm not sure. We'll have to see. You can judge by the length of the video. Let's go over the rules real quickly. So these are killer cages. Digits inside a killer cage add up to the digit, or add up to the number given. So these 3 digits are going to add up to 19. And also digits can't repeat in a cage. So like obviously normally this could be a 5 and this could be a 5 because they don't see each other in the row or the column or the 3x3 box. But here these two can't be 5 because they're in the same cage. Yeah, killer cages are pretty simple. I'll put a link in the description if you want to give this puzzle a try, and let's just get going. So there are a lot of 5 cages, and 5 only has 2 options. And when when put next to a 7 cage, that actually affects the 7 cage. Normally 7 has 3 options. 1, 6, 2, 5, or 3, 4. But if we tried to put 3, 4 in here, or in any of these cages, then the 5 cage would be broken because we take the big digit from every 5 pair option. So these are going to be 1, 2, 6. No, sorry, 1, 2, 5, 6. Okay. I'm not sure how helpful that'd be. Actually, let's do some coloring. I don't know how helpful this will be, but yeah. So if this is, let's say we discover that this is 1, 4, then this one will have to be the opposite of that because it couldn't also be 1. If I tried to put a 1 or a 4 here, it would break the puzzle. So whichever one this one is will have to be the opposite of this one, which will have to be the opposite of this one, and it kind of loops around the circle like this. And that actually does show me one thing. So this cell right here, and I guess every outer cell of the 7 cages, sees all 4 of the 5 cages, and the 5 cages are opposite. So this cell sees 1, 2, 3, and 4 in some arrangement, but all 4 of them. So this can't be 1 or 2. Sorry, yeah, it can't be 1 or 2. So it must be 5 or 6. So let's get rid of the 5 or 6 out there, and then put the 1s and 2 backs here. And I don't know if this will be helpful, but I will color those. Oh, over here, this one must be green as well. Oh, and there's a 4 cage right here, so this is 1 or 3. How does that help? We do have a quadruple here of the 1, 2, 3, 4s. Okay, so yeah, so this does affect things. Oh, there's several things going on. The more obvious one is that, of course, we have 1, 2 pairs here, so these digits can't be 1 or 2 because they see a 1 or 2 in the column or in the row, which is going to force the 1, 2s kind of into the corners. Now we have a 1, 2 looking down, so this can't be a 1 because there's already a 1, 2 pair in the column, so this must be a 3, which is then actually going to make it so it's the random digits I typed in. That's always kind of funny when that happens. Then we can just kind of fill in around the grid. The blue is 2, the green is 1, and that should go like that. Yeah, there we go. Oh, and this one is even set as well by this one. Let's get rid of that color. We don't need it anymore. I know some people leave the colors in as long as possible, but unless I'm doing like full coloring that's going to last the whole solve, I like to remove the colors because it just helps me. Solve, I think. Anyway, so 14 cages that are too large only have 2 options: 5, 9, or 6, 8. So those are both here. Whoops, those are both here. Oh, we have 1s looking in now, so 1 is down here somewhere. This can't have a 1, so normally you would say it's 1, 7, 2, 6, or 3, 5, but I just literally said it can't be 1, 7. And also this digit can't be a 5 or a 6 because the 5 or a 6 is going to be one of the 2 is going to be 1 cage, Let's say the 5 is over here, and the other one will be in this cage. So, like, if a 5 is over here, then the 6 would be over here. So this can't be like that. Yeah. What about this cage? Normally, there are a lot of options, or a decent number of options for a 13 cage. But again, this can't have a 5-6 or the 8-9 because, whoops, because these two 14 cages are kind of claiming those. So this is going to be a 6 or a 9 on this end to finish up the 13 cage with those options. Maybe I can just look at some Sudoku. We have a lot of 2s, which look down here. This must be a 2, because we have these 2s looking down. And also we have these 2s looking over here. That must be a 2. 3s must be over here, which put 3s down here. And this can't be a 3, so we'll mark that. We have 3s looking upwards, and we have a 3 looking over. So we know one of those is a 3. We have a 4 looking down, a 4 looking over, and another 4 looking over, so 4 is over here somewhere. Can I do a little bit more with 2s? We can just pencil mark a couple 2s, and what about these? Yeah. Okay, that's a little bit helpful now. Okay, now I think might be a little tricky. What about 1s? I guess we also can look at 1s in the corners here. 1 must be down here somewhere, and 1 must be over here somewhere. That's not helpful. Well, I guess I'm going to write this in just because I already know 3 is there, but 5 is also forced up here, which means 5 is in one of these 2 spots. If I can figure out what the third digit is up here, I want to remember that I already know that there's 2 of the digits there. But I don't know. Let's look downwards here. No, 5 or 6 could be in here, but 4... Oh, that's it. That's helpful. Okay, so 4 down here can't be in this column, and this column is already or is already filled with just other stuff. So 4 is along here, which means this can't be a 4, which puts a 4 here. Then we can use our pencil mark for 5 and put our 5 there, which then forces a 5 into this cage, because we have this 5 and this 5. And this was the last remaining spot, so that must be a 3. This can't be a 5 any longer. Let's look at 3s. We have 3s looking over. It's down here in the corner somewhere. 6s are also forced over here, so 6 is up here somewhere. What about this column? I guess 7, 8, 9 are the remaining options. That's not entirely helpful. What about 2 in this cage? There was an option for 2 there, but no longer. So this is 1, 2, 4, 7 along these 3 cells, the uncaged cells. But this cage can't have a 1 or a 2 or a 4 or a 6. Is that can't have a 1? There's 2 1s looking over. There's 2 2s looking over. 2 4s looking over, and 2 6s looking over. Oh, and I guess the same is not the exact same, but similar is true for the 19 cage. But this is very restricted. So what are the options? 3, 5, 7, 8, 9. And this is the only. Oh, this can't even be a 3 because of this 3 that we got. But okay, so how do we make 15? Well, I guess the minimums 3, 5, and 7. And then this 3 looks up, and these can't be 3s. This must be a 3. And this can't be a 5 then, so this can't be a 9. And then this can't be a 3, so this must be a 3. Okay, that was helpful. For some reason, I didn't think that 15 cage was very restricted, but yeah, it actually was literally forced. What about this cage? It can't have a 1, can't have a 2, can't have a 3, could have a 4, can't have a 5, could have a 6 and a 7. Okay, that's not quite the minimums. But if it didn't have a 4 in it, then it would be it would be minimum 21 because you'd have to have 6, 7, and 8. So it must have a 4 in here. Does that mean anything? We don't have any 4s looking. What if we didn't have a 6? No, that would work as well. Because that would be 4, 7, 8, and that would add up to 19. Hmm. I see something small. We can write in that these are 7, 8, 9. I'm not sure how helpful that is. Because it sees the 5. Oh, no, it can be a 6 as well, can't it? Okay, well, that's not helpful. For some reason, I thought it couldn't be a 6. I wanted to note that those cells were a little restricted, but I was wrong. What about, okay, this cell is, I guess the middle cage only has 7, 8, 9 left. Or the middle box. Oh, this 3 looks over here, so this must be a 3, so this, or this must not be a 3, so this must be the 3, which takes the place of one of the pencil marks. Yeah, this is the last place, because we have the 6 pencil mark looking up here. And that puts 6 up here, so this is now 1, 2, 6 in the top row. This can't be a 2, this can't be a 1. That puts a 5 in one of these spots. And these both are 7, 8, 9. Okay, so, okay, oh, that's interesting. I don't know if this is intended or not, but this is interesting, definitely interesting. So, these green cells, where can green go in box 3? Obviously, it's not 1, 2, 3, or 6, and it can't go across the top because it'd be in the same row. So these two are the only spots that green can go into. But then we can do the same thing and say, well, where can green go in box 6? And of course, it's not 1, 2, 4, or 5. We can't put them in the same column again, so they must be over here. Well, that does a number of things. 3 is not 7, 8, or 9, so 3 can't be there. So then 3 can't be there. We can then kind of do it again and say, well, these must be green. But more importantly, we can say, if these are 7, 8, 9, we now have a 7, 8, 9 triple. This must be a 6. And this must be a 7. Which makes this a 1, 2, 4. Yeah, I believe so. So this must be a 2 because there's a 1, 4 looking down. And then this, so this can't be a 2, this must be a 2, making this a 1. 4 is looking upwards, put a 4 here. Guess we have a 4 pencil mark up there, which isn't, and a 5 pencil mark. This can't be a 4 because of the one we just put in there. This must be a 6. This is the last spot in the row that a 6 can go since this is blocking out those. So this is a 7, 8, or 9. This might be a naked single, but I'm gonna write in that these are 7, 8, 9. Whoops, 7, 8, 9 first. So let's look at this. Can't be 1, 2, 3. Could be 4. Could be 5. Maybe not. Yeah, that actually. Oh, okay. Well, it can be 4 or 5 at the moment. And then can't be 6 and C 7, 8, 9. And actually, these are a 4, 5 pair in the column. But importantly, this 19 cage, earlier we said it must include a 4. Because if it includes a 6, or if it doesn't include a 4, it must be 6, 7, 8 at a minimum, which is too high. So we have this 19 cage with a 4, and if we tried to put a 4 here, then we couldn't put a 4 anywhere inside this cage. So that must be a 5, and that must be a 4. which means this can't be a 5, this can't be a 9, so we now know this is a 6-8 pair, which does a lot, actually, it looks like. Makes this a 5-9. Makes this not an 8. Makes this not a 6, so it must be a 1. This must be a 7, 8, or 9. Yeah. And, this can't be a 5 any longer because of the 5 we just typed in, so this must be a 5, 7, 5. This is a 7, 8, or 9. Oh, this 6, I guess that's probably been there a while, this 6 looking up and ruling that out. But we see it when we see it. So this 8, 9 is looking over, and so this can't be an 8 or a 9, so it must be a 7. Actually, we have a 7 there as well, so we can remove 7 as options from a few cells. And this one as well. So 7 is in green. So this can't be 7. This can't be 7 just by that. Whoop, by this cell looking over. Okay, here's something. We have 4s looking into box 9. And so 4 is forced into the cage in box 9, which we already knew the 4 was going to be there, but we now know that that 4 is in box 9. So this can't be a 4, which makes this a 4, which means this is not a 4 and puts this as a 4. So that's good. This is 6, 7, oh no, this can't be a 9 anymore because we have a 9 in the row. So this is 6, 7, 8. This is 7, 8, 9 in the column. This can't be a 7. This is 6, 8, or 9. Whoops, 6, 8, or 9. And this is unfortunately 6, 7, 8, or 9. If we tried to put a 9 in this cage, what would happen? That would be 13. 9 plus 4 is 13, and then we would need at most a 5, and we can't put a 5 in. So 9 can't go in the cage, which now gives us a 6, 8 pair and makes this a 9. So neither of those are 9s. One of these must be a 6. Okay, how do we add up to 19 now? Wait, no, back up. Wait, what did I do with that math? 9 plus 4 is 13, which means we need a 6. No, it still works. I don't know why I thought that. The options are either 6, 9, or 7, 8. That was, I don't know, brain fart math, I guess. I don't know what that was. But we do know these two add up to 15. So that, I don't know how much we can use that fact, but I guess this can't be an 8 any longer. If this was an 8, this would have to be a 7, but it can't be a 7, so this can't be an 8. Is there somewhere easier that we can take a look at this? Maybe we can do a little bit better coloring job. Okay, so let's do... Sorry about that, my throat is getting scratchy a little bit. Let's do blue, light blue, and yellow. Hopefully those are pretty different. Let me know ever if I used colors that are like that you just can't tell the difference between. And I'll try to not use those. But yeah, I don't really know what are the like good options for people. Okay, so all the yellows must be the same. I only have one blue so far, but all the blues must be the same. Oh, there we go. Okay, so yellow sees both of these numbers, so it must have a blue inside, which means this must be yellow because it sees both of these possibilities. Hmm. Oh, or I could just do something a little bit more simple. This 6, 8 looks up here and goes there. This 9 sees this, so it can't be a 7. So this can't be a 7, this must be a 7. Okay, that did simplify things a bit. We can now color over here on the left side. But it did not resolve the puzzle. I've used all the cages besides this one, right? Yeah. So this is either 6, 9, or 7, 8. Okay. Hmm. Well, this little stinger at the end of the puzzle has got me stumped here for a moment. Let's... Okay, well, no. Yellow is in one of these two spots, and yellow's in one of these two spots. Fortunately, that doesn't mean anything in relation to, like, if it can be 8 or 9. Oh, no, that doesn't really. So this cell sees both of these digits as well, just the same as yellow over here. This must be the other one of yellow, or it could be yellow itself. Yeah, this is one of the yellow pair, but I don't know if it's the 8 or 9 or the 6 or 7. I don't know how helpful that is. Maybe I don't. If this is 7, 8, this is 9. If this is 6, 9, this is a 7, 8. Which means that this would have to be 9. Okay, so this can't... If this was a 6, that does cause a problem. This would be a 9. Then this can't be a 9, and we can't place 9 in this box anymore. So this can't be a 6. This can't be a 9. Okay, that does help. That does help a lot, actually. This can no longer be an 8 because we see two different 8, 9s in the column. And this can no longer be 8 because we see uh, the 8, 9s in the row. And also, I just noticed I took away a 6 pencil mark. So this would have to be the 6 in the 3x3 box. So these can't be 8. And this can't be 6, and then that forces a 6 into the cage. Nice. Okay. Whoop. There we go. Those are 8s. We have an 8 and 9 looking up. That's a 7. That's a 9. 7. Whoops. 7, 8. 7, 9. A 9, 7. There we go. Not too difficult, though. Spotting that last step was tricky, although I think it was not as tricky as I made it out to be. Yeah. Actually, let's rewind to that spot. Let's. I want to see if there was something else I just realized. Yeah, right here. Oh no, I was gonna say this cell also saw both of these. So I was thinking maybe I could have reduced an option there, but I literally already had that digit. Yeah, so it was there might have been like a Y wing or something. I'm not sure. But yeah, just notice that this can't be a 6 actually. Because that would break the puzzle. Because this cell sees both of them. And there's only a couple spots for 9s in the cage. Yeah, that was a fun puzzle. Let's go back to the end so we can see that. Probably like 1.5 out of 5, maybe a 2 out of 5. Yeah, maybe a 2 out of 5. There was a little bit of trickier stuff. I don't know. I feel like I'm not the best at giving difficulty ratings, but it was a fun solve. I liked. Sorry, my throat is not agreeing with me. I'm not sick or anything. It's just I'm not a talkative person, and I've been talking a lot for these videos the past couple days. So it's just getting exercise when it's not exercised. Uh, I did really like up here how this interacted, and yeah, how it kind of like bounced back and forth and reduced the options in like a symmetrical pattern. That was really cool. Uh, yeah. Thank you for the puzzle, rdndnt. And thank you guys for watching.